All right, I'm back. 4.1, number 11. Let's take the derivative of that. So we're analyzing the first derivative. The first derivative will give us information about increasing, decreasing, and local max mins. So that's what we're up to. And we've done two polynomials. Now we're going to do a rational function. So you have to use quotient rule to do that function. So let's take a look at where this is. Okay, number 11. One thing I'm going to have to realize later that this function is undefined when x is equal to 7. If you put a 7 in here, so x equals 7, I put not x equals 7, or just x cannot equal 7, that's all. That's actually called the domain of the function. Back in the day when we looked at more general graphs, x cannot equal 7. And then if you remember, or if you can look on your calculator, this is a vertical asymptote. So we're going to do some calculus, back to calculus. This is low d high minus high d low, and then down below, low squared must go. So I've got my low, my high derivative of that is 2x, minus x squared times the derivative of that is 1 over that denominator squared. And don't multiply that out, just leave that like that. We're going to distribute, you get 2x squared, so I'm doing this, minus 14x minus x squared, and then these are like terms, so I get x squared minus 14x over x minus 7 squared. Now, we have to first find the critical values, and then we'll put those on a number line, and then we'll test between the critical values. So we have to find the critical values. Now we have a denominator here. So what I do is, if you set this equal to 0, and maybe cross multiply, you can think of it as 0 over 1 and cross multiply, you're going to get this numerator equals 0, but we also have to set the denominator equal to 0 because that's where the derivative, this one is where f prime equals 0, and this one is where f prime does not exist. So this is where the derivative is 0, and this is where the derivative does not exist. We have to take a special step and set that equal to 0 and see what we get. So the ones before, the polynomials don't have denominators, so we're okay. Now, this one I'm going to factor out an x, and then set that equal to 0, and I get x equals 0, x equals 14. And when I set this equal to 0, I can square root both sides. I get x minus 7 equals 0, and you get x equals 7. So I have all 4 of these. That's supposed to be a surprise. I'm sorry, all 3 of these, and put them in order. So I've got a 0, a 7, and a 14. And now I'm going to test in between. I've even whited them out because I think it's easier to fill them in now while we're together. So what do you do when you're doing this homework assignment? Make sure you draw your number line. Put an f prime on it because we're testing our f prime. Later we're going to do f double prime, and it will get confusing if you don't start labeling now. So I'm going to test something over here, and I tested x equal -1. What into f prime? So my f prime is this right here. So I have to plug in -1 into all that. And I did, and I got positive. And really, we don't care what the number is. We just want to know if it's positive or negative. So you put it in your calculator, and when you get positive, you put a plus sign right there on that interval. And that means anything you try in the derivative to the left of 0 will give you a positive. So now I pick something between 0 and 7. I just picked 1. You can pick anything you want. Find f prime of 1. So I put that in there. Now one thing I did observe, that whatever I plug in here, if I subtract 7 from it and then square it, it's always positive. So I kind of was doing the analysis without a calculator. I put a plus here and then put a 1 in here. 1 squared minus 14 times 1 is -13. And that gives me a negative, so I get a negative on this interval. And then you can put in f prime of 8. I was just being lazy here. If I put in 8, so I'm putting in something on this interval, it would be an 8. undefined. 8 squared minus 14 times 8 over 8 minus 7 squared, and this is always positive. You can put the value in, but what's going to be important is that you get for 8 that it's a negative, because you get a negative 48 on top and a positive on the bottom, and that gives you a negative. So this is negative. Now this right here, put in 15. 15 squared minus 14 times 15 all over 15 minus 7 squared. And again, I just did that. This is positive, 15 is positive, positive over positive is positive. So this gives me a positive. Right. Now, what does this mean? F prime, positive. This means increasing, decreasing, decreasing, and increasing. Now notice that I wrote 7 is undefined because it is. It's not, there's a vertical asymptote there. And just in case I needed it, it's just kind of by the way there. Now where this function increases and then decreases, so I'm kind of drawing a little increase decrease, I get a local max, and this one right here goes decreasing to increasing, and that will give me a local min. So I just kind of sketch a little bit, increasing to decreasing, I get a local max. Over here, decreasing to increasing, it's a low point, it's a local min. And let's see if I can fit that in here. This one's a local, I'll just put max. And this right here is a min. We just call them local. All right, let's summarize. So I'm writing a conclusion, and this is all about analyzing the derivative to say something about the original function. F is increasing on negative infinity to 0, union 14 to infinity. F is decreasing on 0 to 7, union 7 to 14. F has a local maximum at 0, 0, and F has a local minimum at 1428. And these values, remember that this is F of 0, you put it back in the original. This one is F of 14, and you are substituting these back in the original. Function F. Because your conclusion's all about F. Now we can graph it. Let's see. I know the window's a little crazy. So I put this in here, put the x squared. Now remember when you put in divided by x minus 7 that you have to put parentheses around that. Graph. And this is not good because I know there's something over here. So let's change the window. Sometimes I'll go to the table to see how high this is going. I see 64, 40. Okay, so I'm going to go to the window and change my max height to, I don't know, 50. Let's see what that does. My Y max, that's all I'm changing just to see what I get. Yeah, there it is, right here. Maybe I'm going to go a little bit farther. Why would I go farther? Because this is about 14 that we're talking about in the x-axis. So my window, let's go to 20. All right, so my x-min was negative 10, x-max 20, and you can change your scale if you want. Negative 10 to 10 to 50 here, and then graph, just to kind of get an idea. Yeah, and there's a vertical asymptote going on here. So what did we conclude? We concluded that f is increasing. This matches it. Up to 0, so increasing up to 0, and then also it increases again over here. It might be easier to actually see it here. My paper straight. Here we go. Because this one we can see all together. So the function increases up to x equals 0, and then we've got decreasing, okay, and then decreases again. Decreases to, what is that, 14, and then increases. Okay, so always take a look if you can, or if you have time, to take a look at your graph. I'll be back.